In today's session, we are going to discuss about the manufacture of DDT and BHC. Before discussing these two topics, we just recall what we have studied in the previous session. In the previous session, we have discussed about the pesticides in that manufacture of 2,4-D, that is 2,4-dichlorophenoxyacetic acid, and parathion. In pesticides, make up an essential segment of agro-business complex. It is very vital for future of the country like India. Pesticides are used to protect food due to destruction caused by various pests, insects, weeds, and rodents. In India, nearly 10% of the total production of food grains are lost by these insects. There are two types of pesticides. One is called systemic pesticides, another one is synthetic organic pesticides, like chlorinated compounds like DDT, BHC, and another type is organophosphorus compounds like parathion, malathion, sevin, saigon, etc. All the pesticides are spread externally to destroy pests by the contact with the plant, and some of the newer organophosphorus compounds acts as systemic insecticides. That means they can be fed to the plant or animal directly, and they are actually circulated by the inner circulatory system of the plant and animal. When these pest comes in contact with the plant or animal, they will get destroyed. And BHC is manufactured by reacting benzene with chlorine. Today we will discuss about the production of DDT or manufacture of DDT. The reactions are DDT actually is produced by reacting monochlorobenzene and chlorol in presence of concentrated sulfuric acid or oleum as catalyst. DDT stands for dichlorodiphenyl trichloroethane. So the raw materials required for this production are benzene, chlorine, and ethanol. Ethanol is chlorinated to chlorol directly, or ethanol can be oxidized to acetaldehyde and then it is chlorinated to chlorol. In the second step, monochlorobenzene is produced by reacting benzene with chlorine, and the final stage of reaction is the reaction between monochlorobenzene and chlorol, which gives DDT and water. Chlorol is prepared by first forming chloral hydrate using chlorination of benzene root. The reaction for chlorol is represented as chlorine plus ethyl alcohol with water gives chloral and hydrochloric acid. Then the chloral hydrate is allowed to distill in presence of sulfuric acid, which desiccate the chloral hydrate to chloral. Then it decomposes chloral hydrate to chloral. So this is the flow diagram for the production of DDT. Here, chlorine and ethyl alcohol are fed to the reactor or chlorinator where chlorol is produced, and the vapors produced in this actually taken to a partial condenser as overhead product to separate hydrochloric acid from the water. The chloral hydrate thus formed is taken out from the bottom of the chlorinator to a still where it decomposes, to chloral. Chloral hydrate is decomposed to chloral. This chloral is actually then taken out, condensed in the water cooled condenser, separated and collected as chloral, is collected as the product. The product chloral is then subjected to further reaction with concentrated sulfuric acid or oleum along with monochlorobenzene. These two are fed to the condensation unit wherein the reaction between chloral and monochlorobenzene takes place producing DDT, and this DDT solution is taken and dried in a dryer and cast into required form of DDT, either flakes or pellets, and then if powder is desired, it is to be ground to fine powder. So this is the process taking place in the production of DDT. The dry chlorine is first absorbed into ethanol at the bottom at a room temperature. The operation occurs in a chlorination tank which produces chloral hydrate and hydrochloric acid. This hydrochloric acid is separated by using partial condenser. Then the uncondensable hydrogen chloride is sent to gas recovery unit, which is recovered by scrubbing with water. The condensate is sent to a still where distillation is facilitated in presence of sulfuric acid. To control the temperature, cooling water is circulated in the jacket as chloral hydrate, conversion to chloral is a sensitive reaction. To manufacture DDT, purified chloral and monochlorobenzene along with oleum or concentrated sulfuric acid is fed to the DDT condensation unit. DDT and monochlorobenzene, the chloral thus formed is treated with lime to remove dissolved acidic impurities. The purified crude chloral is further sent to distillation unit in another still to remove chloral hydrates. Distillation unit is operated in the presence of sulfuric acid and then neutralized with soda ash. The dryer produces DDT powder, which is sent to casting or pelletization process to obtain DDT in the form of flakes or in pellets for sale. The applications of DDT. DDT is mainly used as a pesticide. It was the first of modern insecticides. However, the use of this chemical has been restricted to some degree due to its harmful ill effects. So this is the procedure or process of manufacture of DDT and its application. Next, we will discuss about manufacture of BHC, benzene hexachloride. This is also used as a pesticide. Here, the raw material for BHC are simple benzene and chlorine. Benzene and chlorine are reacted to give chlorobenzene, that is C6H6 plus 3Cl2 gives C6H6Cl6. The benzene and chlorine are passed into a cooled reactor containing a light well, or they may be passed through a glass lined tubular reactor with a fluorescent lamp mounted on the axis of the reaction tube to focus ultraviolet light. This reaction takes place in glass lined tubular reactor in presence of ultraviolet light. The reaction products flows to a still from which the crude benzene hexachloride is obtained as a molten salt at the bottom of water. The unreacted benzene and chlorine are taken as overhead products and recycled. The benzene hexachloride is then dried, cooled, ground to fine powder, and then it is packed. Its application is as pesticide or an insecticide. So this is the process how BHC is manufactured. So today in this session we have discussed about the production of DDT, its raw materials, its flow chart, chemical reactions, and the process how the DDT is manufactured, and we have also seen the applications of DDT. And we have also discussed the production of or the manufacture of benzene hexachloride BHC. It is produced by benzene and chlorine by chlorination of benzene to benzene hexachloride in presence of ultraviolet light in glass lined tubular reactors which produces BHC, which is then taken to a still where BHC is obtained as molten product at the bottom, and the unreacted benzene and chlorine are separated for recycling The benzene hexachloride thus formed is cooled, ground to fine powder and then used. Now let us see some objective type questions in this session. DDT stands for dash. Option A, diethyl diphenyl trichloromethane. Option B, dichloro diphenyl trichloromethane. C, diphenyl dichloro trichloropropane. And D, dichloro diphenyl trichloroethane. The correct answer is option D. DDT stands for dichloro diphenyl trichloroethane. Question number 2. BHC is made by chlorination of benzene dash. Options are A, which is an addition reaction. Option B, which is a substitution reaction. Option C, in absolute dark. Option D, in presence of sunlight. Option A is the right answer. It is an addition reaction. Question number 3. DDT is produced at a temperature range of dash. Option A, 10 to 15 degrees Celsius. Option B, 15 to 30 degrees Celsius. Option C, 30 to 45 degrees Celsius. And option D, 40 to 55 degrees Celsius. What would be the right answer? The right answer is option B. Its reaction takes place with a temperature range of 15 to 30 degrees Celsius. Question number 4. The excess sulfuric acid after condensation of DDT is neutralized by dash. Option A, caustic soda. Option B, soda ash. Option C, sodium chloride. And option D, sodium sulfate. Option B is the right answer. It is soda ash. Next question. Chlorol and chlorobenzene are condensed by using strong dash. Option A, sulfuric acid. Option B, nitric acid. Option C, phosphoric acid. Option D, hydrochloric acid. Option A is the right answer. That is sulfuric acid. Next question. Contact of DDT with iron must be avoided to dash of DDT. Option A, decomposition. Option B, oxidation. Option C, hydration. Option D, dehydration. The right answer is option A. Next question. The chlorol is made by chlorination of dash. Option A, methanol. Option B, ethanol. Option C, propanol. And option D, butanol. The right answer is option B. It is ethanol. Thank you.